Hi roboticists! Today we continue the series on OpenCV Basics for Robotics, handing over from the last video where we have learned how to get the position of the red object in the real world, simulated in Gazebo, getting the data from the camera that we have placed on top of the table. So today we're going to use that precious information for creating a service server that, from a client request, will return as a response the position of X, Y, and Z in the real world of the object that the camera detects. So if you imagine this will be a step forward in building our real robotics application, very common in industries, because this service server will allow us to sense the environment in such a way that we can take action from that. So the action that we are gonna take is to pick the object in the position that the camera detects. And the service server will give us as a response. So before to start, I wanna say you that if you are passionate about robotics programming and you want to develop your technical skill to become a software robotic engineer, well, make sure to subscribe to the channel, hit the notification bell, and if you are new in ROS and you want to be able to understand this coding content, you can check the ROS course for beginner. And this will bring your robotics programming skills from zero to a very good intermediate level in a structured way, saving a lot of time compared to learn by yourself. So don't worry about that, I'm gonna put the link of the course in the description down below with 50% of discount if you subscribe to the channel. So now let's get started. Okay, so welcome back in my Cat King workspace. In the last video, what we did is to create this Python code where we get the position X, Y, and Z of our object that the camera detects thanks to the CV bridge function that I remember you that is going to convert an image from image message that ROS can understand into a kind of message that OpenCV which is a computer vision free libraries can process. So I'm gonna put the link in the description down below about this video. So we are handing over from this. Okay, so what we are going to create here is a service server that will take this information X, Y, and Z. So before to do that, we need to create a service. I already made this service and I have named position tracker. I have decided to create another package in order to do not rely too much on the dependencies in our core packages. I don't want to go into the detail of how to create a custom message and service. This kind of content are deeply explained in the course for beginner, so I just wanna to pass quickly through it. So I have created this package where the dependencies are going to be standard message generation and the message runtime that I put in the package here. And then you have to create or better uncomment this add service file with the name of the SRV file that you create, specifically in a folder that you create named specifically SRV. And then if we go to this folder and in a getPosition.srv file, well, this is the definition of my service. So we are gonna have as a request a boolean variable, and we are gonna name it getPosition, and then as a response separated by these three dotted lines, we have the response x, y, and z position. So we're gonna create a service server inside the OpenCV tutorial package, and based on a request made of a client, and for instance the client could raise a request from the terminal, this service will elaborate the request and return back the response, and in this particular case the response will be the position of x, y, and z that the camera detects, and this value here will be this one, x, y, and z. So we need first to create to instantiate an object in the constructor service, and then here we are going to create a callback function, gets the request from the client and take these values here and gives as a response. So let's do it, but I think that is gonna be a better option to just create another file to do not mix up the things, and update this file. So let's do it. Okay, so I'm gonna name getPosition server.py, and let's modify this in the way that we want. So first, what we need to do is to import the service, and in Python I remember you that we need to do like this. Okay, we're gonna import the service getPosition and getPosition response. This is because it will be very easy to get the response from the service. And then here in the constructor of the class object detection, we are gonna create a server. So I'm going to instantiate a service. So it's gonna be ROS-py. The name of the service, that in this case we can call it getPosition. the type of the service that is going to be get position that has this structure here. And then we need to have a callback function that, since that is belonging to the class object detection, we need to type self and then the name. And then we can have it handle get position. Okay, now to make the things easy, we need to set up the Z value that since that we have, let's say, downsized our problem to 2D by put the camera on top of the object and then updated the mask based on the color by exploiting the lights. So the Z position doesn't change. Okay, then the variable x, y, z, we need to get into a position that the function can take. Okay, perfect. So the value self.xpos, ypos, zpos are ready to be get from the handle get position callback function. So now let's create this, and this is some kind of, this will be treated like a method of the class. And then we're gonna pass the request that we call rec. Then I remember you that the request is gonna be of type boolean. So if request is true, then we create a get position response object. So let's call it res. So we are going to instantiate an object get position request. So we are gonna get, so we are going to instantiate an object of type get position response. And then we are going to assign the value that the response need to display, or better, gives to the client when the request is raised. So res dot x position, okay, because this is how the service is structured, x underscore position, y and z position. Then I remember you, it's gonna be here. So res dot x position is gonna be equal to the value that we have set up here. So self dot x position. Let's do the same for y and z. Then, since that for the moment the client, we're gonna raise the request from the terminal, so the terminal will be our client. So we're gonna display on the terminal a message with the actual position of the object that we get in that moment when the request is raised. So to do that, we're gonna type rospy.longinfo, and then what we want to be displayed on the terminal. Here you are, and then finally we need to return the response. Okay, that's it. So before to try, we need to compile. Let's run the simulation. Okay, the simulation is running. So if we run this code, let's see what's happened. We should get the image like in the last video, where we get the position of the object in the coordinates of gazebo. Let's see what we have. Okay, perfect. So the position in X is going to be 1000 millimeters, so it's going to be 1 meter, and Y 0. But remember that this position displayed on this image will be the position that the object has here in this environment. So if you want to check again, just click to the object, go to pose, and here you can check the value. So first of all, let's check what are the services available, and to do that you need to type ROS service list. Let's looking for the service that we want. Okay, get position. Perfect. And then what we can do now is to use this terminal as a client to raise a request to the service get position. So let's type ROS service. Then we need to call the service that is gonna be get position. Okay, and if you type tap, you see that you get a request get position that is belonging is embedded in the type of message that you wanna that you have in this service. So this is a boolean value, so let's make it true. Okay, perfect. You can see now that what we get here is the position in X, Y, and Z of the object as a response. That is the same that we have here. So if you wanna try again, so what we can do is to displace this object somewhere else in the table and see if the service can really get the updated value. So we have displaced it here. Let's see what will be the position, the new position. Okay, it's gonna be 1020 1 and then 170 millimeters. Let's raise a request again, and then you can see that the values are updated, and this value x, y, and z are the same that is gonna be here. Okay, that's all for today. I hope that you enjoyed this kind of content. I think that you can appreciate the fact that you are making a step forward in our robotic application, because we have created this server, services server, that can get the position of the object that has been detected from a camera. And in the next video, what we can do is to exploit and get this information to give to the robot application, where the robot needs to actually pick that object. And what we're gonna do is to create a client in our Cobot test package and in our pick and place application. So I don't wanna reveal the secrets for the moment, but if you wanna see the next video, make sure to subscribe to the channel, hit the notification bell to do not miss the next topic, which is gonna be very interesting. And if you like this video and you appreciate this kind of content, just let me know your thoughts, or simply give me a feedback in the way that I've explained, and raise a request to me if you want me to deal with a specific topic that you have to face in your company, or in your, let's say, in your ROS development journey to becoming a robotic software engineer. Again, thanks for your attention, and keep learning robotics with ROS.